So now that I've talked about the executor completion service at a high level and giving you kind of a conceptual overview of what it does, let's do a deeper dive and look at its key methods. As you can see, there are just a few of them. And these methods that are part of the completion service interface are implemented by the executor completion service class. And then we'll spend a little time visualizing the executor completion service in action, which will do a better job of showing why you can have multiple threads submitting tasks and multiple threads taking the results back when they're done being processed. Very simple interface, just a handful of methods. There's really only 3 method names, 2 of which are overloaded, so really a total of 5 methods. There's methods for submitting a task for execution, and as you can see here, both these methods return a future, but you typically ignore that future. You don't care about this future because you're going to get the results back through take or poll, as we'll see momentarily. About the only reason you would ever want this future would be to cancel the task if you wanted to. That would be about the only reason why you'd want to keep track of this. The first method here submits a value returning two-way task because that's what callable does. So here's the callable interface. As you can see, you call, and then you get back a return value. So it's a two-way operation. One of the cool things about this is it's an asynchronous processing model, so you don't actually have to block on the future. Like I said before, the only reason you'd use that future is to cancel things. There's also another submit operation that submits a one-way task, which does not give you back a result, although you could give some kind of faux result here just if you needed one. This is not widely used. We typically use the two-way approach here. And that implements runnable, which as you can see does not return a value. There are 3 methods for retrieving the results. Internally, all these methods will access a blocking queue, which can be, which is implemented by the system, that will keep track of the tasks that have completed. So things don't show up on this queue unless they're done. They're futures, but they're completed futures. The future that you get back from take and poll, or either the poll operations, is guaranteed to never block when you call its get method. And that's because you don't show up on the internal queue unless the future is completed. And once the future is completed, then of course when you call get, it'll never block. You might ask, why do we return a future? We'll talk more about that in a second. It's basically to be able to differentiate between successful versus unsuccessful completions. The take method blocks for the next completed task, and that means it could wait if there's nothing in the queue. And when there is something in the queue, it's going to go ahead and retrieve it and remove it from the queue. And not surprisingly, under the hood, this is going to use things like reentrant lock and condition object that we talked about in previous discussions. The poll method with no parameters will check to see if there is a result, and if so, it'll return it right away. Otherwise, it'll just return null. So it doesn't block. It's like a try. It's like a try-take, if you will. It's a polling operation. And then the second poll method takes a timeout, and it'll wait up for that amount of time to get a result. And if it gets it, it'll give you back the future. Otherwise, you get back a null. OK, so those are the methods. You can see they're really, really simple. That's what makes this framework fun to use. It's very simple to use once you know how to connect it together with an executor of some type. So let's go ahead and visualize how this thing could work in practice. And as we'll see, this particular instantiation of executor completion service defines an instance of this that uses an executor to run the tasks, which are then added to this internal blocking queue when they complete. And as we see here, we can have a bunch of threads submitting tasks and a bunch of threads taking the results. So you can have one or more threads submitting two-way tasks to the thread pool, and then one or more threads can handle the results of these tasks. You could just have one thread. You could have one thread that spawns all the work and then waits for the results. You could have pools. It's up to you to decide how you want to arrange this. So we start off by having some client thread submit a two-way task, so that gets given to the system. That task is converted into a queuing future, and then that queuing future is executed on the thread pool, and that goes ahead and will enqueue it to be processed at some point. When there's a thread available in the thread pool, and let's say for sake of argument this is a fixed thread pool, so we've got 4 threads, then one of the threads will wake up when it's its turn, it'll pull the queuing future off the queue, and it'll go ahead and run it. And when it's finished running, then its done method is called. That's what queuing future provides, a done method implementation. And the done method implementation on the queuing future goes ahead and adds the completed future to the completion queue. So it gets stuck on the queue here. And then when some client thread calls the take method, or the client thread could have called take right away, when there's something on the completion queue, take will then return from blocking, if it was blocking, waiting for something to be on the queue. It takes it off the queue and then returns that as a future, and then it can go ahead and process it by calling get, which will get the result. So those are the basic steps. You can see there's a lot of moving parts if you look under the hood, but mercifully, you as an application developer don't care all those steps. All you care about is the fact you submit two-way tasks and you get the results when they're done in the order that they complete. So that makes it very efficient and very convenient to use.